Yeah, hi there. In this tutorial, we are continuing with exploratory data analysis. We are going to cover pandas underscore profiling library in this particular tutorial. So usually when we specify df.describe while doing any EDA, we get a very basic type of data analysis like um, minimum, maximum, 25 percentile, 50th percentile, and so on. However, if you want to extend that feature, then we can use pandas underscore profile library. It provides a quick data analysis along with a lot of charts. So to do this, I'm using the data set, which basically contains uh, the statistics related to the players who have played in the test matches and scored at least 10,000 run in their overall career. So first I'm importing libraries like pandas, import pandas SPD, and also I'm importing pandas underscore profiling. So if you have not installed pandas underscore profiling, then you can install it using pip install pandas dash profiling. If you want, then you can specify the specific version like I have done here 2.8.0. And once it is installed, then we can import it using import pandas underscore profiling. I'm just checking the version of pandas. So pandas version I'm using is 1.0.3. And to check the version of pandas profiling, I'm using this command pip freeze and grepping for the pandas profiling. So this shows that the pandas profiling profile installed on my machine is 2.8.0. Okay, now time to read the data set. So I'm reading it from a CSV file. This is what the data set is. So it contains the name of the player, the team for which the player played, number of matches played by the player, number of innings, runs, total number of runs scored by the player in his career, what was the average number of centuries and number of half centuries. So this is a list of all the players who have scored at least 10,000 runs in their test career. So if I just quickly display the whole data frame, I get a number of records as 0 to 12, that is 13 such players are there. Now let's do some basic EDA using describe function. So df.describe and include equals to all. If we use include equals to all, it will also include categorical variables. Otherwise, it excludes categorical variables and gives you the EDAs only on the numerical variables. So what we get here is the name of the columns and the statistics it is performing. So for example, like count, since there are 13 records, so I'm getting 13 for each of these columns, so there is no missing data. Then in terms of the uniqueness, so there are 7 unique teams. I mean, players belonging to the 7 unique teams who featured in this top, who are featuring in this 10,000 club. Okay, and there is a top command which represents the most frequent one, so it's Australia, and the frequency is 3. Now these columns like mean, standard deviation, minimum, and other 25 25 50 75 percentile and the maximum, these all apply to the numerical column. So there is nothing for the categorical column. So if you see, there is none for each of these, for these two categorical columns, player and team. Okay, so okay, this is what we got based on this df underscore describe. Now let's move to our the topic of the interest today, that is pandas underscore profiling. So how do we generate the report? So we use say pandas underscore profiling. That's a library that we have installed, and using the method profile report and passing the data frame to it. Then title of the report that we want to appear in the report output, and we want explorative equals to true. By default it is false. I want to uh, calculate more statistics related to the data frame. That is why I've specified explorative equals to true. Now once this is done, we can generate the report within the Jupyter using in an interactive fashion using profile.toWidgets. So this is what we get the output. If you see, now we'll just quickly explore it. So let's look at this tab, overview tab. So overview tab, so that's a high level overview for this profiling. So number of variables are 8, number of observations, if you see, there are 13. since there is no missing data in any of the columns, so you get missing as 0. Similarly, in the percentage as 0. Duplicate, there is no duplicate row, so duplicate is also 0. And total size occupied by data frame in the memory, it's 2.5 KB. And the average, what is the average size of a record in this data frame? We are getting it. So that's the overall high-level summary. Next thing is how many numerical and the categorical variables. We have two categorical variables, player and team, and rest of the numerical variables. If we go to the next tab, which is reproduction, it says that at what time this particular analysis was started, when it completed, and how long it took, which version of pandas profiling I have used. If we want, we can create the same sort of report from the command line using this particular command. All we need to do is we need to use this config.yaml file. That is actually another yet another markup language format file. It's similar to like we have JSON file. In JSON we have key value pairs. Similarly here also, but instead of those brackets and all, it is more or less space indented formatted. Okay, there are some warnings. We'll cover warnings later. Let's start with the variables. Okay, so for each of the variables, that is for each of the columns in the data frame, we are going to get output. So let's start exploring. First column is the player. So player we have 13 distinct because the name of the player is different for all the rows. So obviously we will get distinct record for this. So okay, and is any missing? Yes, there is no missing data. So it means this is fine, and we can get the name of the players and the frequency. If there is any duplicate, then it will show the duplicate. So that is fine. Let's move on from player to, and it tells that the type of the variable is categorical. Cool. Next is the team. So team again, it's a categorical variable, and distinct count is 7. So it means the players belong to 7 different teams. So if I want to see how many players belong to which team, we can just have a quick look at this plot. So you see 3 players from the Australia, 3 players in from India, 2 players from Sri Lanka, 2 from West Indies. These are the players who are present in this 10,000 club, test club. Yeah. Let's quickly move on to the next column, matches. So it's a real number, that is it's a numeric column, and there are 11 distinct values. So this is what the distribution it is like. Okay. So minimum number of matches played by any player to score 10,000 runs is 118, and the maximum number of matches played by a player in his career who has scored at least 10,000 runs is 200. That is fine. So we get an idea. Okay, based on the based on the career of the players who have scored at least 10,000 runs, and the average number of matches they have played is 154. Now moving to the next column, innings. Again, it's a numeric column, and so the mean value is 263. So on an average, players have played 260 plus innings in their career, minimum being 213 and maximum is 329. And then again, this particular column is specifying the size in uh, size in the memory occupied by that particular column. Runs is the total number of runs scored by a player in his career. So you see that the minimum is 10,099, maximum is 15,921. So maximum obviously is by Sachin, and minimum I think is by Yunus Khan. Okay, and we get so the average of the runs is 12,208. Okay, now next column is the average column, and again similarly the statistics like minimum, mean, maximum, and so on. And another, now this one is interesting, the number of centuries is scored. So if you see, uh, so the players who have scored at least 10,000 runs, the minimum number of centuries scored is 27. I think that's by Allen Border, and the maximum number of centuries is by S51. I think that's again by Sachin. So, and most of the players have scored, so average is 36. So most of the players have scored centuries somewhere around close to 36 in their career. Okay, and now the next column is the 50 is the last column. So mm on an average, players have scored at least 54 half centuries in their career, minimum being 33 and the maximum being 68. So if you see, this is what we are getting the different statistics related to each of the column. Along with that, the possible chart is coming. So we are getting both uh, data uh, in the number format as well as in the visualization format. Now again we can go to the next tab, the interaction tab. So in the interaction tab, basically it creates uh, kind of a scatter plot on the x-axis and the y-axis. So we can choose the different. Let's say if I want to choose on the x-axis as the innings, on the y-axis I want to see the runs. So if you see, x-axis is the innings and the y-axis is the runs. So obviously a positive correlation. So the more number of innings played, the more number of runs scored by players in their career. Yeah. So, and again, let's say innings and hundreds. So this is how it is. So players who have, let me change matches here and I put hundreds here. On the x-axis, I have matches, number of matches played, and the number of centuries is scored. So you see a high number of data points somewhere here. So in this way, we can find out the interaction between the two variables. Again, there's a correlation which we can see from -1 to 1. So the variables which are highly correlated will have a dark blue shade here, and the variables which are not correlated will be white colored, and the negative correlation is represented by the dark red color. Again, any missing value, since all the columns have values, so there is no missing value, so obviously it's complete, and then we can get some sort of sample data if we want to. So this way we can generate a quick descriptive exploratory data analysis using the pandas underscore profiling function. So if you want to generate the data in the form of HTML report, we can use profile.toNotebook underscore iframe. So it will generate the HTML report within the same notebook. And if we want to save the data in a HTML file, then we can save it using .to file method of. So by using profile.toFile and specifying the name of the output file, I can save the output in the HTML format or in the JSON format. So let me just quickly check the output. So this is the HTML file, and if I open it, let me choose Chrome. So this is the HTML file. So within a matter of few minutes, we get a very decent looking exploratory data analysis done by using pandas underscore profiling library. So this provides a very detailed analysis. So if you see, there is a column, there's a toggle details coming. So if you want to get more details about it, then you can click on the toggle details. So if you see, currently you get some basic statistics here. Now if you want to see like histograms, common values, extreme values, then also you can get details. So yeah, so this is in addition to the exploratory data analysis that we had done manually, in which we had run all the commands manually. This is also a quick way to, just quickly execute it and on the data frame and develop a quick understanding with respect to the data and its variables, how they are related, correlated, how the distribution looks like, missing values. So these kind of things we can done using pandas profiling. Obviously, the manual way is like we are having more control if we are doing it manually. There we get, you know, we can customize the charts that we want to with the different colors in terms of different look and feel. But before going that, we can get a very the look and feel about the data using this pandas profiling in a very short span of time. So that's it for this tutorial. Thank you.